Hello everyone, welcome to my YouTube channel CNC4TDM. In this video, today we are going to discuss geometrical tolerances. Earlier we have already discussed the dimensional tolerance. Now it is geometrical tolerance. What is geometrical tolerance? Here if you see geometrical tolerances, these are three types of geometrical tolerance. Geometric means shape of the object, or it is form tolerance. It is three types of tolerance are there. Geometrical tolerance is form tolerance, orientation tolerance, and position tolerance. So here what is form tolerance? Means shape where it has no other reference, only shape of the object. Just like straightness is there, straightness, flatness, roundness, and cylindricity. So these are form, shape of the object, that tolerance, geometry of the object. Orientation tolerances are just like parallelism, squareness, angularity. So orientation means it has some reference. Parallelism means there is some reference. With that reference, surface would be parallel. Squareness means it is perpendicularity from any reference, from datum should be there, and similarly angularity. So these are orientation tolerance. And third is position tolerance, concentricity. Position means position in x axis, y axis, ordinate of the object. So that depends on the concentricity. We will discuss in detail all these things. Okay. Now, if you see here, first thing is we have discussed what is straightness. So this is a cylinder, and this diameter and these limits, tolerance limits are given here, 19.86 to 19.89. That means this tolerance is 0.03 mm. Here this tolerance is given, this is 0.3 mm, 0.3 mm tolerance. So it should be straight within 0.03, means in within 30 microns this surface should be straight. This diameter in the whole length, so maximum tolerance is 0.03, and this tolerance is for straightness. So here if you see, this is called here feature frame. This is sign for characteristics for straightness, the straight line. It shows it should be straight, and this 0.03 is the tolerance value. So this is the tolerance value, and this is the symbol for straightness. That means straightness should be within 0.03 for this cylinder. So this is an example. So if you see here, this is tolerance is given 0.03 mm, and this shape, this is like this. So if any deviation is there in the shape, so that deviation is allowed only 30 microns, 0.03 mm. So this way we define straightness. Okay. So next thing is this tolerance is roundness. This is here is roundness. This symbol is for roundness here, round symbol. It is for roundness. This characteristics is for roundness. And this is tolerance value is given here 0.05 mm. This is tolerance value. So this diameter, whatever is the diameter, so this diameter, a tolerance value is 0.05, and roundness is this. Roundness means any error in the roundness. So it should be perfectly round like this. This is roundness, and if there is some error in the roundness in this diameter, so the shape may be like this, something like this, or there may be some error in the roundness. So that error, permissible error in the roundness, due to machining, in the machining operation there may be some error, and this maximum error in the roundness that is allowed is 0.05 mm. So this is tolerance given here, and this is tolerance for roundness. Okay, so this is roundness tolerance. And next, if you see, this is flatness. This symbol is for flatness, this like this. This is a flatness symbol here, and this is tolerance value. So Flat means a surface would be flat within an area. When area, if you define some area, and in that total area, this is a permissible tolerance value. So if on the surface there is some waviness or some deviation is there, so that deviation, straightness means in a single line, flatness means across some area. This is area. If you make these two lines straight and then maximum deviation on the whole surface, so that is the permissible flatness error. So this way, this is given here, this may be 20 micron, 30 micron or whatever it may be. So this is flatness of the surface. Okay. And then next is cylindricity. This is cylindricity. It is symbol for cylindricity. One round diameter is there and there are two lines like this. So this is cylindricity error. So this cylindricity error, it is actually, it is a roundness plus straightness. If we add both these things, then there will be cylindricity. Cylinder means across the length also, cylinder. Across the length, if there is some error, permissible error, this is given here, shape. And in the diameter also. In the diameter means roundness. In the diameter, if there is some error, it is given here. This is for roundness. This is for roundness here. And this is for straightness here. So if we add these two things, roundness and straightness, then it becomes cylindricity. So it is the total permissible error which is called cylindricity. If you move the dial on the top surface like this here, and also on the this, if you rotate this job also and along the length also, if you see, then total permissible error, that will be cylindricity. That error is called cylindricity. So this way, these are the form error. These four things: flatness, cylindricity, and then roundness, straightness. So these are form errors, shape errors. Okay. So next thing is, these are orientation. Means one is, if you see here, this is squareness. Squareness means perpendicularity. This is the sign for perpendicularity here. This feature frame is there like this. Feature frame. In the feature frame, if you see here, there are three things. One is symbol, perpendicularity. Other thing is value, 0.05, tolerance value is given here. Third thing is A means this is datum. A is a datum. This surface is datum. Sorry, this is datum, A here. So we define datum like this in the square. If you write some letter, this A, and you make a triangle here like this, so this becomes a datum symbol like this. So with respect to this datum, so this is our datum, and if we check this perpendicularity along this line, so this perpendicular surface, it should be perpendicular within 0.05 mm with respect to A, with respect to datum. So this way we define squareness or perpendicularity. So squareness or perpendicularity error we can define like this. Okay. In the orientation, then the next thing is parallelism. Parallelism means one surface should be parallel. This is sign for parallelism here. Symbol, characteristic symbol, geometrical symbol like this, two parallel lines. And this is given here, value is there, tolerance value, parallelism 0.005, 007 means 7 micron. Okay. And then B is given, this is datum reference, B is datum, means with respect to this datum should be there. In orientation, datum is first. Okay. So M is for material condition, whether maximum material condition or least material condition. This is a separate topic we will discuss later. But you should know only if M is written here like this, then this is a material condition. Okay. So this is tolerance value, and this is sign of parallelism, and this is your datum B. So datum B is given here like this. This is your B. Maybe it may be a surface plate or anything, the datum surface. Okay. And this permissible value is given here, 0.007. means this 7 microns value for this, and so this surface should be parallel to this, parallel to the datum. Datum is this, and this is the bottom surface, and this should be parallel with respect to the datum and within the value of 0.007 mm, that means 7 micron. So this way we define parallelism. So and next thing is in the orientation, next thing is here angularity. If you see here, this is angularity. What is angularity? It is the angular error. This theta angle is given here. This is some angle is given like this, and this is tolerance value given here. Angle, it may be 30 degree plus minus 5 second, 10 second, whatever. So in that this is the tolerance value. Angle may deviate from the original line. It may deviate to some other angle, and that value is given here, and this is datum is also given here. This is datum. So our for angularity sign is only like this, just like one angle. So this is angularity. We define it angularity orientation. So this way we can define this also. Okay. Then next is concentricity. So this is the symbol for concentricity here. This symbol, double circles, these are concentric circles like this. This is symbol for concentricity, and this is the value of the concentricity. Tolerance is there 0.007 mm, and this datum is there A. A is the datum. So with respect to A, where is the A? This is datum given here. That means this is a datum. This diameter x-axis, this is a datum. With respect to this datum, this y diameter, it should be concentric within 0.007 mm. Means this center of this diameter and center of this step diameter y, this should be maximum permissible error is 0.07. Both should be concentric circles. If these are not concentric, then there will be position error always. So this way we can define all these things. So this concentric circle is there like this. There are two circles, and this is the symbol. So this is called concentricity, and this is position error. Geometrical characteristics like this. So this way we can define all these things. So these are all geometrical tolerances, and we can define like this. So we have already discussed these things: straightness, what is straightness, what is flatness, what is roundness, and what is eccentricity, and then parallelism, squareness, angularity, and then concentricity also. So this way we have completed all these things. Thank you for watching. Please like, share, and subscribe. Meet you soon in next video. Thanks.